Okay, guys, good morning. And after weekend, it's gonna be like again very hectic sessions for coming week. So I'm planning with different activities for you guys. And so today we are gonna discuss about something the classical neural networks, the classical architectures by scientists for the computer vision community. Okay. Okay. This is called a classical computer neural networks. We will start with the couple of architectures. Okay, we'll go with that. Right. Now, classical computer neural networks. Our journey to computer vision started on long back. It's like it's 1950s story. The first paper, the neural network was LeNet, LeNet 5. What is one? Keep note on this. LeNet 5 is proposed by Anne Lukun and Lukun in 1998. This paper was published in when? This paper is published in 1998. At that time, there were no much improvements to any network, any neural networks. This paper is related to the convolutional neural networks. Keep remember this. This is for image processing. Image processing. This is the first paper for grayscale images. It's not a RGB images. It's in a grayscale images. Grayscale images. Right? Now, what is the main thing you need to learn or keep remember out of this LeNet? The major thing you should remember for this LeNet is LeNet has also used non-linearity activation functions such as sigmoid and tanh. In this paper, they did not use below elements. One is ReLU were not used, and the second one is there is no concept called max pooling, and there is no option called padding. These three options are not been introduced Introduced in where? It's a LeNet. Guys, so far is clear. If you are clear, I can write the architecture. I can show you the how this process completed from a given image to softmax. I can write on this. So if you are understood this LeNet, type LeNet in a chart window. So okay. So when you speak about LeNet, right? When you speak about LeNet, we are not being like okay. Okay, I'll use this color. Is it visible? No, it's not visible. Okay, I'll use the green. Okay. So what are the disadvantages? What are things not used? They didn't use max pooling and they didn't use padding. They didn't use reload. Because of this no using of the padding, data is getting shrinkage. So number of width and number of height is always keeps on decreasing. Only one thing gets increasing, that is channels. Number of channels will increase. Which one is decreased? Width and height is decreasing. Subsequently, number of channels will increase. Okay. Now let us see how this architecture LeNet architecture in detail. Right. Let us have my input image of a number. They are working on the what one? They have done the paper presentation on the basis of MNIST data. MNIST data. So dZ. I want to classify the dZ. It is a grayscale image of 32 by 32 and 1. What I have done with 5 by 5 and stride of 1. What will be my output size, guys? And you need to tell me what will be my output size. If you have followed my classes yesterday's the 4 classes, you might have the answers for this. So what will be the size? (28 by 28). Okay. Imagine I have a filters of 6 filters I used. I'm using the filters equal to 6. What is this? 28 by 28. Again, I have the number of channels. This number of channels keeps on increasing. This weight and height and width is gonna decrease. Here we are using the average pooling. What concept they used? Average pooling and filter equal to 2 and stride equal to 2. So what will be my image shrinkage now? So what will be my image? Okay. Okay. 14 by 14. Right.
Yeah.
Now it is coming down to 14 by 14 and 6. What I am using? I will be using 5 by 5 again and stride equal to 1. So my image gets shrinks towards 10 into 10 and 16. Again I will be using average pooling of stride of 2, filter of 2. So I will get 5 by 5 and 2. 5 by 5 and 2. Now I'll be using, I'll count here. What is this? 16. Sorry, I'll having the 16 filters. So if I multiply this, what is the value I'll be getting here? 25 into 6, 400. I'll be using fully connected layer. From there I'll be taking 120 values. From there I am taking again fully connected layer with 84. From there I'll using the softmax is y hat of 0 to 9 numbers. This is what whole story behind your LeNet process. Here what is missing here? Here in this architectures, it's a basic model for computer vision. It's a basic model for your computer vision. Here no max pooling. So I'm using average pooling. It is been downsampling every time. When I use average pooling, it is downsampling. Then there is no padding here. And every time I am using convolutional, I am using the tanh or sigmoid. No ReLU was being introduced. ReLU was introduced in next architecture by AlexNet by Geoffrey Hinton. We call Geoffrey Hinton is one of the, he got the Nobel Award in the computer vision in the last year. Guys, is this clear? LeNet architecture. Any confusion? Guys, let me know. If you have any, if you are clear, type clear. Otherwise, you ask me where is your doubt. You unmute yourself and you can ask me. It's a plain neural network which has been introduced for computer vision in 1998.
Sir, can you show that calculation of 400?
5 into 5, how much?
That is, sir, 16 or 6?
16 filters, right? I have the
Okay.
16 filters, right?
Okay. So 25 into 16 that should be, right, sir?
Yeah. 25 into 16 will be to 400, right? 25 8 is equal to, see, 25 8 is 200, 25 again 8 is 200, 400.
Right, sir. Okay, come.
Got it?
Yes.
Now, this is got clear or not clear, everyone? So here in a LeNet architectures, there is no other option.
Suresh, how is 28 got converted to 14?
Sorry?
28 into 20 into 6 is equal to 14 into 14. How?
See, we are done applying the average pooling, right? We are not.
Is there any formula or how?
Normal formula only, right? Average pooling. Instead of taking the pixel values into max pooling, we have done the average pooling. When we done the average pooling, it will be downsampling to the half.
Okay.
Your image will be downsampling to the half.
Okay. So here, from first it is 16 only, no? Right?
Sorry?
First one is 16 only, no? 28 into 20 into 16, right? Or
Six filters. 6 filters.
But in the third one, 10 into 10 into 16 it came.
Here they were used 16 filters.
Okay.
16 filters. I'll
random number, right? You can use anything. You are using just 16.
So they were used that one. Prasad, I'm showing that calculation in a deeper way. Huh? Now, can you see here?
Yeah.
Can you note down this? Okay. Here, one more point. LeNet have the parameters of around 60,000. How many parameters we got? 60K parameters. I request you to write down this image, this diagram completely. This is the basic important thing. You need to finish that, and once you complete, just you mention me completed. So the authors for this is Anne Lukun, Botu, Bengio, and Hartner in 1998. One second. You can write down. Here I am just saving this architecture. Instead of this, I can use this. This is only convolutional operation and average pooling.
So first it is 32 into 32, right? And again it converted 28 into 20. How is this transform?
Prasad?
The first one.
N minus 1 plus f, right?
Okay.
Huh?
So here it is normal one, and the second time it is average polling. That's right.
Yes. First is convolutional only, right?
Okay.
See
First is
here,
convolution. Next is average polling.
average polling. Here
Okay.
they have
Okay.
used 6 filters. How many filters they are used? They used 6 filters here. 6 filters. Again they are used 16 filters. 16 filters. That's how it goes up. -32 minus 5 plus 1. How much, Prasad? 28 into 28. And I have how many? 6. Is this fine?
Yeah. Yeah.
You forgot the formula. Huh? So everybody noted down this diagram.
Copying, sir, copying.
Copy here. It's a basic thing you should understand. कैसा होता है?
Completed, sir.
Everyone.
So, can you explain me? I was getting confused between 2D convolution and 3D convolution, sir.
See, we are not working on a 3D now. Okay, we are just going with 2D only. So
Okay.
2D only. 3D is that was started like 1 month back only. The 3D convolution by PyTorch. It's a very long way, and people get confused.
Okay.
Who is this?
Aniket, sir.
Aniket. अभी बहुत time बाकी है to understand the 3D. I'll tell you after end of this computer session. The most of the architectures are based on 2D only. Okay?
Yes, sir.
Right? See, the people might be in a different stages, but we should not confuse. I can teach you 3D also. Right? But we.
So,
The
but
people,
at this moment, 2D will be enough, right, sir?
yeah.
You know.
See,
Got
the 3D implementation has not been done so far. They have done it theoretically, and there are only couple of proposals has been made on a 3D convolutional. Am I
Okay,
making
sir.
sense?
Yes, yes.
So just wait on that. Copied? Okay, done. Very good. Very good. I want this kind of people that I need to see. Some of the people they won't copy. They say that I'll Google it. See, Googling thing will not help you in all the ways. Now, we will go and see LeNet 5 complete architecture. LeNet 5. Open LeNet 5. I'm opening on the LeNet 5. This LeNet 5 paper published for what? It's a grayscale image. So here we are taking about we have taken the fashion MNIST, right? We have seen the fashion MNIST. Now I'm just importing the necessary documents. Okay. This lead load extension of Tensor Board, we are gonna use Tensor Board extensions to save our performance in a Tensor Board, like this way, like here. You could see the Tensor Board, right? You can see this way. There you can increase the smoothing also. You can download this accuracy. Now if you can see this kind of graphs I can create. At what step the value is this, and what step relatively I can show all the values. Okay. For this we are using the Tensor Board here. We are using the option called Tensor Board. Okay. For this calculations we need to have a flatten layer, and we are using what pooling? We are for LeNet, as we discussed, we are using average pooling, right? Am I making sense here? I'm not going to use max pooling, or I'm not using any padding here. I'm not using anything. So I'm just using average pooling and convolutional. These are the things. Okay. Right, I'll write down here. As per paper implementation, you are using two operations. One is convolutional, and average pooling. So if this is clear, type 1. Why we imported only these two? As per LeNet 5. LeNet 5. Clear? If you are clear, type 1. Why we are only imported only convolutional and average pooling. Now we go back. So we discussed our goal is to LeNet 5 recognize the handwritten digits. Instead of that, we are using using fashion MNIST. So we take the input of 32. That's how it will become. So we are importing the fashion MNIST. This code is present in. If you want to try, you can try it here. The code is available in the GitHub. So this code is available in here in this GitHub. If you wanted to try parallelly, you can try to do it. If you want to try, I'm just giving the link here. You can copy this link and you can start your collab. You can do that. So fashion MNIST. I'm importing fashion MNIST model. Right. I'm just checking the print checking the shape of input and its number of samples. This activity can also refer to be multi-class classification. How many have completed the cats and dogs in the last class which I had told? I don't think so. Oh, I don't know how many people has done it. But I request you to do it. That will give you the complete picture. See here, my training shape, my total data having 60,000 records with 28 by 28 of the size, and 28 by 28 of 10 training, and 60,000 is a training, and the test is having 10,000 images. Now, we checked the shape of the new data is set to be 28 by 28, the image pixels, so that we need to add a new axle to represent the number of channels. We need to have a 28 by 28. For a grayscale image, we need to represent number of channels, right? So I'm adding the new axis with number of channels. So here number of classes. White train, when you see the white train, it will be having 0, 1, 2, 3, 4, 5. So the white train will now we'll write down the comments here. White train is having the target variables such as varies from 0, 1, 2, 3, and so on 9. Right. For machine learning, it treats as it cannot treat equal. It has conflicts. It will have the conflicts for sure. Conflicts. So we are converting into, if it is a 0, this will be converted as like this, 0, comma, sorry, 1. For this will be 1. The rest of things will be 9 zeros. How many it is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 1, we are converting this as into 0 and 1. This is how we need to create. Because every class is important, right? Every class is very important. That's it. So what we have done here, y test. When you see y test, you're gonna see random variables. Like I don't want to see everything. I just wanted to see y test of 0. Now see, this how has been created. Get convert the class vectors into the binary class matrix. So is this way same way it got converted? Is it clear? If it is clear, type binary. Now, okay, how many of you are practicing? How many of you opened this Google Colab? Only 3 people opened. 4. Okay. Okay, good man, good. You continue working. Okay. Now I'll be executing this. I have executed, right? Now we are doing the okay, use. Here we are doing normalization. Normalization for better computing. For better computing, by bringing down the pixel values from 0 to 255 to 256, 0 and 1. Now it is coming here. Now it is time to use the TensorFlow now to build a convolutional neural network. The easiest way to do the sequential API will wrap. This is called LeNet 5. So as discussed in the name, the LeNet 5 is having 5 layers. How many layers? We'll see. 1, 2, 3, 4. Maximum is a 5-layer network. 1, 2, 3, 4, 5. These are the 5-layered network. Here, valid equal to, here is input is same and here valid. So valid means it will downsample the data, right? So if I were not see the while inputting, this is what the same padding will be the same. When after doing the convolutional, after using average pooling, they are mentioned the valid. So what will happen? It will be downsampling, right? Will this option will make you the downsample or not? Now I'll write down the comments here. As discussed in class, they were used as LeNet progress. As a LeNet, data transmits, data being forwarded to next layers. Data gets shrinks. So here in this below you can see the activation functions are used what? Used manage. Manage. I want to make it. This has a bold. How to make it a bold? TANH. In order to use, they have used the TANH here. Can you see here? I have used number of classes 10 and my activation function is softmax because I'm doing what? Multi-class classification. If this LeNet architecture is clear, if you are clear, type LeNet architecture. Aniket, which paper is this? LeNet 5. Aniket, what is the doubt? Can you unmute?
So I was thinking of asking which implementation is this of LeNet, like for the paper, if I could go through the
LeNet 5 only, right?
right, sir, right. That is the basic architecture. That is what.
We are discussing about LeNet only, right? If you
Yes.
want the paper, I can show you the LeNet 5 also. I'll LeNet 5 paper. If you want to read, you can read it. And look, this is what a LeNet 5. It's in 1998. Check it out. This paper.
Okay, sir.
This is what we are discussed, right? We are talking about only LeNet, right? Talking about LeNet paper. This was the complete paper with 40. The other time there was a huge number of. See, this is the LeNet. Aniket, is it making sense? This
Right,
LeNet
sir. Right.
paper, this LeNet
Right.
paper is been like, you can go through it. It's very like at the time they were written this one. The earlier papers was very lengthy. Now the researchers or scientists are being smart, so they are making our papers now like 5 papers. Like now here, see, you could see this is the LeNet original paper. This is what the actual paper was been given in this 1998 publications.
So no, I was asking the code you are implementing. Is it from any like the MNIST one?
This one.
Was that some like PyImage or IEEE standard or that specific? I was asking. Is there?
No, I'm just using the same concept of strides and number of pools. This one average pooling and everything on the paper only, right? This,
Right.
if you go back and see this paper only, I'm implementing. So why are you worry about PyImage search or whatever? You write your own code. Keep in mind that what is the layers they are used. See here,
Okay.
you're getting my point.
Yes. Yes.
This is what I have implemented here. That's it. So when it is said that model equal to LeNet dot number of classes. As discussed in the paper, the LeNet has told that how many parameters, Aniket? LeNet have 60k parameters, right?
Yes, 60.
Approximately it has the 60k parameters of training. What's this? Good one. This is also good one actually. This is also good explanation.
I think this is the right, more concise one.
See, this if I believe that if you go that way, you will get struck. Okay, even it's good actually. Thanks, thanks, Lokesh, and I'll keep referring this paper. Okay, now I'm being like, see, you can see the LeNet having the parameters of 61,000. Now, what is the next step I'm gonna do? I'm gonna train it and I'm gonna use callback option. Okay, why are we using callback option? What is the purpose of callback? Aniket, callback. Why are you using callback? Why do we use the callback? What is the point? Early stopping. So for early stopping, we use the callback option. If the model is not improving, so I'll be keeping as a verbose equal to 2. Let us try in this. What's happening here? Where is the shape? Now you see the training is started. Now see this will improve because it's in a grayscale image and also it is being taken an account that it's very clear images. So here no need of any other techniques to solve the issue. But this is not the real case. Believe me, this is not at all the real case. You cannot get this kind of accuracy in like 10 epoch or something. We may need to train the model extensively. See, my accuracy has been improving over a period, not like decreasing. So I got this one. I'm loading the Tensor Board. Now you see the beauty of here. Loads. Wait. Can you see here? I'll zoom it. Now you see. Now you can see. For epoch 1, step 1, step 2, step 3, step 4. Like what is your accuracy for the train and test? So there is a, what is the difference now? What is the train accuracy? Training is accuracy is 95 and 89. So it's some sort of overfitting or underfitting. Ash,
So it's underfitting.
it's a overfitting. See, keep remember that whenever training is good and validation is less, so it's an overfit. It's failed to generalize. So whenever you are failing to generalize more, like it's not bad. If it is like 89% is good. If it is like 50%, it's bad results you can see. Now if you go to this graphs, you can see the different graphs and you can, I request you to see here. This is what my graph. I'll one second. Here you can see I'll make it this. So I have, guys, can you see here? So here we have a dense layer and, oh sorry, now you can see the graph. I have an input, convolutional, average pooling, convolutional, average pooling, flattening, dense, dense. This is what my convolutional, right? This is what TensorFlow is giving me the beauty of the graph. It gives me the beauty of the graph. I can fit this to screen. I can fit this to screen. It's not happened. Now you see, I can drag anywhere and then I can understand, or else I will go through this. Huh? I don't know, something is getting failed. So input data type and values, my output. Okay, here if you see the dense layer having 8 graphs. Here dense 2 is having only 1. Here if you can see, based on our input, we can see the values. In convolutional, what is happening? 8 subnodes. How this image been input 28 into 28 into 1, my output, how this data been transformed. You can clearly visualize everything here, everything this format. It's a very beautiful thing why TensorFlow is given to demystify your this one, black box of learning. So now I'll go and validate whether the given classes are I'm gonna predict now. What I'm going to do now? Predict. I'm gonna predict. See, if you wanted to go all this kind of warnings, at the end you use the colon. What is the thing you need to use? The colon. That's it. So ankle boot, everything, sandal. So whatever red has been categorized as incorrect predictions. So red is incorrect predictions, whereas the blue is a correct predictions. That's it. Very simple. So this is what correct predictions. I'll go with a blue, and incorrect prediction I'm going with red. That's it. Very simple. I hope you also executed in your systems. If you are completed, let me know. I'll go to the other topic. Hello? Guys, can you go on mute? Who is doing? So have you done implementing from your side in your Google Colab? If yes, let me know. Where we will go to other topic for the same. Guys, your implementation is done. Prasad garu. Guys, are you
No,
there?
not at Suresh.
Oh, doing or do not yet?
I started, but can we do it afterwards after the class because it take time
Yeah. Now,
so that will not waste.
huh. No, there is nothing called waste or something that. Here, there is something called. I told you right yesterday we were discussing about. Okay. How to train your machine learning, build a machine learning model without writing a single line of the code. Meenakshi, you want to share the screen? Okay. So when you click this, it will goes to this point.